All right, geometry. Today we are looking at section 10-7 of the textbook, which is page 660. If you do want to follow along, we're talking about areas of circles and sectors. Sectors are, as you will see in a moment, just part of a circle. So example, A, B, that's like a sector of this whole circle. So first, let's just remember area of a circle equation. If we were in class, I would definitely ask someone to tell this to me because I know you know it. That area of a circle is pi r squared, where r is the radius, or pi diameter divided by 2 squared, because their radius is half of the diameter. Or, that's the same thing if you are to distribute the exponent pi d squared all over 4, because 2 squared is 4. So all of these equations are equivalent. It just depends on whether you're given a radius, which is like OB. OB is a radius, or the diameter. The diameter would be, if we went all the way across to some part C, like CB would be all the way across. Diameter OB halfway across is the radius. So let's think about how to find the area of a sector. If the whole circle is pi r squared, the area of the sector is just the measure of this angle over 360 as a ratio times either, pi r squared, any of these, because all we're doing is finding what portion of the circle is in the sector. So let's say that this was 32 degrees. Then the measure of the area of the sector would just be as a ratio 32 all over 360, since 360 is the full circle, times pi r squared. Whatever the radius is. The radius would be OB. All right, let's do some examples here. So the first one, we are given the area of a circle with a radius of 2 inches. So we're given the radius. That means we want to use our radius equation of pi r squared. So that becomes pi times 2 inches squared. And that 2 becomes squared. The number goes first, then the pi, and then we just have inches squared. Because inches is also squared, that is why area has our squared units. All right, this next one, area of a circle. Once again, it's pi r squared. Here it's pi times 6 centimeters squared. In this case, 6 squared is 36. Then we have our pi, and then we have centimeters squared. This third one, now I have diameter. So diameter means I either want to use this equation or this one. Let's use this one. So we have pi diameter divided by 2. So first we divide by 2 and then we square it. So that means it's pi times 6 over 2 squared. Order of operations means first I do 6 divided by 2. I get 3 units squared. 3 squared is 9. Then I have pi, and then I get units squared. This would have been the same as if I had squared 6 first, gotten 36, then divided it by 4, it would have still been 9. So this is just showing these two are equivalent. All right, that was it for full circle. Now let's say we have a sector. A sector is just a portion of a circle. So we use our area of a sector equation. So the measure of AOB, that is 60 over 360, meaning that this is going to be 1/6 of the circle, because 60 over 360 is 1/6. And then I need to multiply by pi, my radius is 2 feet, and square it. This is just my area of a sector equation from up here. It was the measure of the angle over 360 times pi r squared. So 60 over 360, we can reduce that to 1/6 times pi times 2 feet squared. All right, sorry, that got cut out for a second. So 4 feet squared over 6, that's 4 divided by 6. Well, we can divide both by 2. That gives me 2 over 3. I keep my pi here, and then I bring down my feet squared. So this area of this little sector right here is 2/3 pi feet squared. And we did that by finding the area of the full circle, which would have been pi 2 feet squared. That's the area of that full circle. But then we're just looking at 1/6 of the circle because it's 60 degrees, and the whole circle is 360 degrees. So we take that as a ratio to find 1/6 the area of the full circle. All right, let's do the same thing for B. So you notice we don't have an angle here, but we have this little measurement, which hopefully you remember means 90 degrees. So let's start with our area of the sector equation. The angle is 90 over 360 times pi. Here my radius is 3 units, and I square it. So let's reduce 90 over 360. Well, 90 goes into 360 4 times, so it's 1/4 times pi times 3 squared is 9, and then units squared. Then I get 9 over 4 pi units squared. So I'm just moving this number over here to simplify our answer. So really, the area of this full circle would have been 9 pi, because 3 squared is 9, and then we have a pi for our area of a circle equation. But we only have 1/4 of the circle, so we take 9 pi divided by 4, because it's 1/4 the area of the full circle, units squared. All right, last but not least, we have this whole shaded area. Now, there is a problem like this. This whole circle is 360. This part is 30. So then this angle is going to be 360 degrees minus 30. Make sure you do that. That's 330 degrees. Because I want the shaded area. So the area of this sector is 330 over 360 times pi times 10 yards squared. Now let's see. 330 and 360. We want to figure out what number goes into both of those. I'm pretty sure 30 does, for sure. So let's think about how many times 30 goes in. I think 30 goes in 11 times to 330, and then 12 times to 360. So it's 11/12 times pi times 10 yards squared. 10 squared is 100, and then I get yards squared. So then I have 100 times 11, which is 110, 1100 over 12 pi yards squared. If you want, you can make that into a decimal, but you really don't have to. I prefer we just leave it as a fraction, because you'll see in the future when we use this for a future calculation, it's just easier to leave it. We believe in ourselves, we believe in each other, and we believe in Our Lady of Tepeyac.